National Conference on Emerging Technologies 2023 Spectrum of Opportunities. To give a wonderful welcome to everyone gathered here, may I take the pleasure of requesting Ms. Needu K., Assistant Professor of Computer Science and Engineering Department, for the welcome address. Ma'am, please.
A very good afternoon to all. It gives me an immense pleasure to welcome all of you for the valedictory function of Ncet 2023. I would like to welcome our chief guest, Dr. Fawaz, Assistant Professor, Department of Ship Technology, Ncet. Welcome you, sir. I welcome
Thank
our honorable CEO, Salim sir. Welcome, sir. Teaching and non-teaching HODs, teaching and non-teaching staff for RCET, and all the participants of Ncet 2023. I once again welcome all of you for the valedictory section of Ncet 2023. Thank you.
Fragrance of flowers spread only in the direction of the wind, but the goodness of a person spread in all directions. Ladies and gentlemen, we are delighted to have Dr. Fawaz PK, Assistant Professor in Department of Ship Technology, Ncet, Kochi, as the Honorable Chief Guest of our valedictory ceremony. He has been working as the Assistant Professor at Department of Ship Technology of Ncet since November 2020. He had worked as lecturer in mechanical engineering at MES College of Engineering, Kuttapuram, from 2004 to 2008, and as ad hoc faculty at NIT Calicut. He also served as assistant engineer in Kerala Water Authority. He had published a total of 4 journal publications and 18 conference publications. He is an eminent professional who had published 2 books and numerous awards and honors, which includes Certificate of Excellence in Reviewing from NIT Calicut in 2020. I invite the Honorable Chief Guest for the valedictory address. Sir, please.
Thank you for nice introduction, and happy to have participate in this valedictory function of National Conference on Emerging Technologies, organized by this esteemed institution, Royal College of Engineering and Technology. I had a lot of previous although I didn't visit this institution. Many of the previous principals had close association, and I could get a lot of information and updates about this institution. And let me share my slides.
Yes, sir. I will stop my presentation.
Okay.
Sir, now you can start your presentation.
Yes. Whether the slides are visible now?
Yes, sir.
Okay. If any in between any issue is there, you can tell me. Any voice is not breaking, any issue is there, you can tell me in between. And all the participants also, if any issue is there, you can tell. And the topic for today's presentation is the future of computational predictions. And this is, although it seems to be a very simple topic, but in the future, whenever we are thinking about the future, it is basically integration of a lot of fields of knowledge. And also, in line with the theme of the conference, spectrum of opportunities, this will create a lot of opportunities in the coming era. And whenever now the trend is that whenever we are getting something and a new topic, and the trend in the new gen is that what ChatGPT tells about that, or the Google Bard tells about that. Now, even if you are the same topic, if you are asking about the future of computational predictions, one of the drafts we are getting from the Google Bard is that there are a lot of applications for this, or a lot of the computation production, the future, a lot of points they are mentioning by the Google Bard. That means one of the AI-based tool. And the areas they are mentioning is one is the weather forecasting and the financial forecasting, and also the medical diagnosis. And all these are, and also how the course of treatment, best course of treatment can be decided. All these are what we are getting presently from the AI-based research engines. Now we will have a look on the past, or the past regarding the computation. Or we can tell about computing before computers. How was the computing performed before computers? And during the programming courses, computer programming courses, and other courses, you might have gone through, or we are going through the different mechanisms for computing. Abacus, we know very well, and some tables based on the abacus, and a lot of improved versions of abacus were used in China as well as in Japan for computing. And later, mechanical calculating machines. Several mechanical calculation machines like a Pascal's machine and Leibniz machine, based on all these words are mechanically operating. Especially we have mechanical engineering stream, and as part of this conference. And a lot of gears and gear-based arrangements, mechanical arrangements were used for calculations. This is also how the mechanism of the Leibniz machine. You can see that a lot of gears and wheels, pinions, shafts, all these are there in such mechanical calculating machines. And some more advanced mechanical calculating machines came later in the 19th and 20th century. This is one of such calculating machine. And Millionaire, another calculating machine. And then the history of the modern computers. And we know the scientists like Charles Babbage. In 19th century, actually happened the development of the modern computers. Analog computers were the analog signals. Now we are extensively using the digital computers, analog signals like electrical, mechanical, or hydraulic quantities were used to model the problems being solved. One of the 1960s analog computers, you can see the size and how the arrangement is there in the analog computers. And then whenever coming to the digital computers, we know that the ENIAC, electronic numerical integrator and computer, now it was 75 years was completed. Only 75 years completed for we can see the women programmers in history they are operating the ENIAC. And then the different generation of the computers, the first generation computers using vacuum tubes, second generation using transistors, third generation ICs, and then the fourth and fifth generators using very large scale integration, VLSI, ULSI, and microprocessors, etc. So this evolution of the computers, we know, and this evolution of the computers, computing, and one of the you can see what happened with the C, and the computational power, and also the computational storage capacity. All these increased tremendously during this growth, and this table indicates how it has improved from 1951 to 2007. One of the and even after that, if you can see that again, such a tremendous growth can be seen from 2007 to 2023. And here, and also the price of the computing, and also that also you can see that, and that is seen in the terms of an adjusted price. If with an adjusted price, how much price is there for the computer, and how is the performance or additions per second or calculations per operations per second that has increased in from the UNIVAC to the whatever the AMD or Intel Pentium 4, 5, 6, etc. It has improved a lot, and this also caused a lot in the computation predictions for the engineering problem solving. Although computers have evolved with parallelly, but the increase in the speed has caused a lot of applications for the engineering problem solving. Now in the present, if you are coming to the present, we have the physical space, human society, and the another space is the information space or the virtual space or the data space. And this is the three-world theory of the present. And along with the development of the computing power, another issue we are facing is that the generation of heat from these sources. And all the computers have become miniaturized, and we have handy or pocket-sized computers. But the number of chips, all their number is increasing, or density or the space is very limited. That means the heat generation is increasing, at the same time the size is decreasing. This is creating a lot of issues, and one of the prediction is telling that it will even not to lean to reach the heat generation of a nuclear reactor from these small sized devices. A lot of accidents we are nowadays reporting, bursting of the battery, and all these such cases are nowadays reporting from the media. Then the cooling of these computers is also another area, along with the increase in the computational power and computational speed. We should have some technologies for the cooling of the computers and computing devices. And while coming to the engineering prediction, in any branch of engineering, we have different methods of prediction: experimental, analytical, and numerical, basically. And we are doing experiments in laboratories, and we are finding out with respect to some independent variable, how the dependent variable is varying, and how is the performance. Different performance curves are plotting for irrespective of the engineering branches. And then we are having another method, analytical method. That is basically we are solving the mathematical equations pertinent to that particular problem. And then numerical methods are also there. That means numerically we are solving the problems. And these computations and growth of computers have contributed a lot to the development of the growth of the numerical methods and the acceptance of the numerical method. The numerical methods are basically a subset of the mathematics. We have numerical analysis there in the mathematics. Generally, in the beta curriculum, the third or fourth semester, numerical analysis is taught. Numerical methods in engineering is there. But the growth of computers or computational speed, that have also caused a lot of acceptance for the numerical problem solving or numerical methods in engineering. That means fastly we can get the solutions from the numerical methods. The experimental methods are generally, it may take time and also costly. A lot of apparatus setup, all these are required for the experiments. And while coming to the numerical prediction, which are generally done with the help of the computers, the cost is less, speed is very high, and you are getting the complete information, and different conditions can be simulated for very small and very large geometries, very slow or very fast processes, and even if the toxic substances, flammable or explosive substances, or nuclear reactors or nuclear reactions, which are having a lot of side effects, all these can be simulated using this numerical prediction. And we are having, whenever I know many are from the BTech final years have presented a lot of papers in this conference based on the project. That is a very good step. And whenever we are going to whenever we are practicing engineers, many problems we may have to solve numerically. And the basis is some of the numerical methods of engineers. For engineers, Stephen Chapra and Canal is there. It is a very good book. And we can parallelly practice a lot of problems, simple engineering problems, with the numerical methods of solution. This is another Indian author by Yogesh Jaluria, Computer Methods for Engineering, with the MATLAB applications. So you can there are some sample codes are there. That is, it is not specifically a particular engineering. That means problems are solved from civil engineering, mechanical engineering, chemical engineering, electrical engineering, different domains of engineering. The problems are solved. Engineering problems are solved using numerical methods or computer-based method. And here it is with MATLAB, and some other literature and books are available with Python, C. All these are available. So it is recommended to solve some problems using computational methods. And in any of our engineering problems or engineering subject, basically what we are doing is that we are developing a simple mathematical model. If any engineering subjects we are taking, it may be a fluid mechanics subject or a solid mechanics subject, or any other doing is that we are explaining a physical process and trying to develop that or process or physical engineering process in terms of some independent variable and dependent variable. How the dependent variable is varying with independent variables and some parameters and some forcing functions. How this relation development or this relation derivation is the basis of our is the basis of any engineering subject. Or we are at the end of the subject or the end of the module for a particular engineering subject you are studying. What is happening is that there may be the derivation of a particular equation subjected to that physical phenomena. Such differential equations are very common, and sometimes maybe algebraic equations. Algebraic equations are very easy to handle. But whenever it comes to differential equations or complex differential equations, and you can see that in mathematics, physics, chemistry, biochemistry, economics, everywhere differential equations are there. And whenever coming to the engineering problem solving related with fluid mechanics, solid mechanics, and chemical species or mass concentrations, mass species related to mass species, we are using some general principles of nature, like a law of conservation of mass, law of conservation of momentum, law of conservation of energy. Then we are formulating integral or differential forms. And sometimes the differential equations may be ordinary differential equations or partial differential equations. We have to solve them. And these partial differential equations may be linear partial differential equations or non-linear partial differential equations. And there are some mathematical nature of the equations are also there. Elliptic equations may be there, like a Laplace equation, Poisson equation in mathematics. Then parabolic equations may be there. Hyperbolic equations like wave equations may be there. So these type of governing equations we are basically deducing in our engineering subjects. The next task is to solve these differential equations, ordinary differential equations or partial differential equations. How we can solve? One is analytical methods. Whatever the methods studied in mathematics, we can apply to solve highly complicated partial differential equations. There are some limitations for the mathematical methods or analytical methods. And you have studied some methods of separation of variables. Or whenever the equation is the form of mdx plus ndy, you might have studied in the partial differential equations. Then only for certain forms of the partial differential equations, direct or analytical methods are easier or available. Then the next choice is that we go for some neural methods. And we can have such a domain where the partial differential equations related with fluid flow or fluid dynamics that can be solved with the help of computational or numerical methods. And such an area is emerging for the last 3-4 decades. That is basically computational fluid dynamics. And this computational fluid dynamics, or generally known as CFD, can be applied in a lot of domains of engineering applications. Hydrodynamics of ships can predict the drag force, or we can predict the resistance offered by the offered on the hull of the ships using the computational fluid dynamics. In aerodynamics, we can have it. What is the drag and lift in the drag and lift forces in aerodynamics can be predicted with using computational fluid dynamics. What we are doing is that we are solving the law of conservation of mass, momentum, and energy, and their relevant partial differential equations we are solving using some numerical techniques of mathematics using computers. That means now itself a lot of branches, domains of knowledge are combined there. Mathematics is there, and computational science is there, programming is there, or computer application is there, fluid mechanics is there, mechanical engineering is there, and many other engineering subjects are also coming there. And even you can see that a lot of one of the interesting studies that was after this COVID outbreak was that social distancing, and we should keep 1 meter distance or 1.5 meter distance or 2 meter distance. How that distance was decided, and a lot of studies are there. How much of how from the snoozing of a person, and the viruses will reach to how much distance. That means the basis of the social distancing was predicted using computational fluid dynamics, and the design of the heating, ventilating, and air conditioning systems, HVAC systems, and how the airflow is there. And during that COVID outbreak, one of the issue was that the HVACs. Usually, we have that tendency whenever we are entering an AC room or AC air-conditioned vehicle, people will always tell that close the window, close the door, so that the energy efficiency, that means whatever the cooled air is not escaped to the surroundings. So that we are cautious about that. But what happened after COVID, and there were suggestions in newspapers or by health authorities that air conditioning rooms should be open and it should be ventilated. And even in the hospitals, the number of air changes per hour, that was one of the important parameter. How many times air has to be changed in a room or a clean room or in a hospital or in a theater or where a COVID affected person is there. So all these predictions were done with the help of computational fluid dynamics. And another area was in the medicine, circulating tumor cells in blood, the tumor cells or cancer cells, how it is circulating and how it is interacting with the walls of this blood vessel. And such studies are there. And recently I got a chance to attend such a session by Dr. Ncet of NIT Surathkal. He has done a lot of research in that circulating tumor cells in blood. And then tsunami effects on bridge pillars have done by a lot of researchers. Flow of cerebrospinal fluid, intracellular fluid, pulmonary flow, all these are predicted using computational fluid dynamics. Then flood prediction is another area, the dam collapse. And you might be remembering in newspapers during the 2018 and 19 floods. What will happen if Mullaperiyar dam collapses? And how many hours? There were some pictures in the papers and some simulations. How many hours? Within how many hours Kochi will be flooded like that. That means all these can be predicted using the solving the mass equation or continuity equation, momentum equation. All these equations, if you are solving partial differential equation, we are solving computationally using some CFD methods, we can predict that. And the division of pollutants, and even we had the issue of Brahmapuram. And now there was a discussion within how many kilometers that will be affected, and that can be predicted. How these pollutants are diffused through air, soil, and water, and in what rate, and what will be the affected area. All these can be predicted using computational fluid dynamics. And another interesting area, especially for the new generation, is the cricket ball dynamics. So you can search in the Google Scholar, you can find out how the cricket ball or is dynamics, seam, swing, spin, and all these are predicted or studied using CFD techniques, cooling of electronic components, nuclear reactor safety. All these are another areas where CFD finds applications. And basically, this is solution of some partial differential equations using numerical methods. And one of such these are some partial equations. We are not going in detail. These are related to the fluid dynamics, Euler equations when they are inviscid. Whenever it is frictionless, whenever the friction is also considered, viscosity is also considered, then it will be Navier-Stokes equations. That is one of the basis of the computational fluid dynamics. We are solving the law of conservation of mass, that is continuity equation, and the momentum equation in the x, y, and z directions using some computational techniques. That is the basis of the computational fluid dynamics. That is presently all these studies are taking place. The only point is that the studies are now in different areas of biology, chemistry, chemical engineering, mechanical engineering, and different applications. It is now it is finding newer and newer applications. We can see studies based on the computational fluid dynamics. And in all these solutions, if we are talking about some of the fundamentals, if these partial differential equations, all the partial differential equations will be having infinite number of solutions. To limit them into some particular number of solutions, we need to apply some boundary conditions. So in any computational fluid dynamics problem solving, there should be some boundary conditions should be solved so that some realistic boundary conditions are required so that we are getting some unique solution to the problem. There are different types of conditions. A dependent variable value is specified, or its derivative is specified. This is a Dirichlet boundary condition. Another one is if derivative value is specified, Newman boundary condition, and like that, different type of boundary conditions are there. So that knowledge is also, some mathematical knowledge is also important in the case of computation fluid dynamics based problem solving. And then we are finding out some independent variables, dependent variables, some primary quantities like velocity, pressure, temperature, etc. will be predicted. And using these primary quantities, some secondary quantities like wall shear stress or drag force, heat flux, all these can be determined. And we are having some ODE dy by dt is equal to a function of dy. This we are writing in another form. Now you can see that what is just some two examples I'm seeing, not seeing lot of mathematics. This dy by dt is a function that we are rewritten as another form yi plus 1 is equal to yi plus f into delta t. Now you can see that this is a ODE, ordinary differential equation, and the other one is a linear equation. So this transformation for this techniques, generally it is called as a discretization techniques in computational fluid dynamics. We are transforming a ODE into an approximate linear equation or algebraic equation. That is what is happening in computational fluid dynamics. And these algebraic equations then we are solving using high-speed computers. And another partial differentiation, another difference is that these are continuously varying functions. You can say continuously varying function. But this continuously varying function in a 2D domain, you are finding out the solution only at discrete points. So that is why this is an approximate method. You are not finding out the solution at a continuous domain. You are finding out only at the discrete points using computational fluid dynamics. And that is basically another limitation with the computers also. And then there are some you have to be cautious about the errors, since it is an approximate method, or instead of dy by dt, or each and every point the slope is varying for a curve, but you are finding out the slope based on some discrete points. So that means it is an approximate method, and some error will be there obviously. You can see a comparison given in the numerical methods of engineers by Chapra canal. Exact analytical solution or mathematical based on the analytical solution of the partial differential equation, if it is like this. The other one is only at some discrete points, and there will be, it is the approximate and numerical solution. Some error is there. And we can reduce these errors by some techniques. And if you are cautious about the errors, and by properly choosing the grid size and many other parameters, we can reduce errors. But it is an approximate method that should be there in our mind. And this computational fluid dynamics problem solving is generally now done using some programming languages like Fortran, C, C++, Python, or some open source software packages like OpenFOAM. This is one of the extensively used one, and ModFlow, etc. And some commercial software packages, ANSYS, Fluent, StarCCM+, MATLAB. All this can be used for computational fluid dynamics based problem solving. And there are obviously used in that some error is there. Like truncation error means error in the formulation. Other one is the round off error, because the computer will be chopping off some after some significant digits, some error. So this you should have a vision on the errors also. And what this conversion to algebraic equation in CFD is basically done. What we are doing is that we are discretizing the equation. And the partial differential equations you are transforming into an algebraic equation, and then we are solving by that are solvable by the computer, and we are solving by the computer. And there are different methods like finite difference method, finite element method, finite volume method, etc. for this discretization. That means partial differential equations you are converting into algebraic equations at not a single point, at thousands of points. That means thousands of algebraic equations you are obtaining, and manual solution of these thousands of algebraic equations may be quite difficult. Then we are going for high speed computing. And you can apply in almost all branches of engineering. This, if you are taking the marine transportation system, underwater vehicles, surface vehicles, submarines, autonomous vehicles, everywhere there are a lot of applications for this CFD-based problem solving. And the drag force can be determined, and the engine efficiency can be determined. And we can some ship CFD simulation, hydrodynamic resistance force, and here the velocity can be, sometimes it is also called as colorful fluid dynamics. That means a lot of information can be simulated in colors, but the insight is also very important in this. And you can see that the velocity along an autonomous underwater vehicle, AUV, and the velocity, the different colors, you can see that the red is the highest velocity and blue is the lowest velocity, where the highest velocity is there, and where is the lowest velocity is there. That means the friction or some, it is not smooth. Wherever the smoothness is there, there will be higher velocity will be there. And the pressure, where the pressure is predicted using some ANSYS-based computational fluid dynamics package. And these are done by some scholars and available in literature. And here also how the pressure values are varying at different locations. And for the heat transfer prediction in marine engineers, marine engines, shell and tube exchangers, refrigeration, ship loader, marine boiler, everywhere for many problems we can use that. And you can see that the engine in the cylinder of the engine, an IC engine, how the velocity is varying, velocity magnitude is there, and such predictions can be done, simulations can be done using computational fluid dynamics based software packages. And IC engine combustion simulation. This is a combustion simulation, and how the temperature is, where the temperature is high, and all these are predicted using computational fluid dynamics based packages. And for the solution of the nuclear fuel elements, because experiment is very dangerous, and then its cooling can be predicted on nuclear submarines and their inside how the nuclear reaction and its cooling, and there should not be any nuclear accidents, and that can be prevented, or such studies can be done using that. Means nuclear meltdown has to be prevented in the nuclear submarines and nuclear power plants, and that can be predicted using computers with the help of the computational fluid dynamics tools. And even the cooling of the fans in the computing, even inside the computers, we can have some applications of computational fluid dynamics. The design of the fans, SMPS fan, case fan, all these can be how much air circulation is there and how is the cooling is there. There also we are solving the continuity, momentum, and energy equation. These partial differential equations we are transforming into algebraic equations, and we are solving using computational fluid dynamics. And even in our laptops, the heat pipes are there for carrying away the heat and using computational fluid dynamics. And even in the centrifugal pumps, the vorticity magnitude, vorticity can be predicted using computational fluid dynamics. And even in our health, or that means asthma spray inhaler injection into the lung, and how it is, if a spray is inhaled, and that spray, that means that medicinal part reaches the lungs at what concentration each part, that can be predicted using computational fluid dynamics. You can see that this is such a spraying into the human lungs, ANSYS fluent training. This is a training module of the ANSYS fluent they have given in their website. So how that means this is basically the particle residence time. How much time a particle is there in the lungs can be predicted using computers. And we can see that this is an open form, that's an open source based. And common grids, ancient common grids. The water is flowing is predicted using the flow is simulated. And even in the vehicles, there is a vehicle aerodynamic simulation is there, and safety simulation can be done for the aerodynamic study of the vehicles. And here this was done using star system indicators, and total pressure of how much the pressure, why the stream, how the streamlines can be predicted, and a lot of such applications can be done. Particularly, all this can be predicted. And if for the racing car simulation, we can use that. And if a 2D simulation of car aerodynamics, how the flow is there in the case of a car, you can see that in these colors are basically a transient analysis or an unsteady state analysis for a particular time step. The velocity and velocity plots are simulated, And this is another a vehicle body that is generally called as Ahmed body, a simple a car type shape. And using that, how will be the what will be the pressure in a situation? So we will consider a domain that is generally called as computational domain near that particular body or near that car. And in that area, in that field or domain, we are predicting entire part of that domain. At discrete points, we are predicting the pressure using computational fluid dynamics. And for the aeroplanes, also full aircraft safety analysis is there using for the lift and drag coefficients. All this can be found out using computational fluid dynamics. Then aircraft performance is done using similia.
It is well understood that optimal.
And in the process industries, also we can have some mixing, how the mixing is done in the chemical industries or processing industries, and that solution time or mixing performance, blend time, all this can be predicted using computational fluid dynamics studies. And some interesting studies also you can see that how the straw for drinking the juice, for now you can see that one opening is there, another additional opening is there for the straw other than this opening. So how it will be and how much particle from the that is the bottom opening that is entering through that is reaching the other end, its concentration. All this can be studied using computational fluid dynamics based simulations. And then in the pharmaceutical industry and biotechnology industries, all these industries we can have that. And in plant breeding, in agriculture also, crop modeling, there are many, some of the online assessors using computational based prediction in agriculture. You can see here. Now we are talking about the last 10 minutes, we'll be talking something about the future. Now, whatever the present studies we have how the computational fluid dynamics based predictions are there in all the branches of engineering, all the fields of human life, and all the fields of science and health, medicine, agriculture, engineering. Everywhere such predictions are now existing there, and more fields are now shifting towards the computational. Now there is some experimental setups in the ship test. Now we have some boards or ship testing, stability testing is now that is discussion is there in the media, and many such towing tank arrangements are there that is having crores of rupees investment is there. Now whatever such experiments can be done with the same accuracy in using computational fluid dynamics. That much capability is there for the computational fluid dynamics or computational methods. And in the future, what will happen? One of the domain is the computational fluid dynamics that we have already discussed, and now the other areas are coming from the computer science based domains, like or electronics based domains are there, and these terms are we are discussing nowadays in extensively artificial intelligence. And even now, in the AI itself, another area is explainable AI. That means logic can be explained, or explainable AI is now getting much attention. Even at Cochin University, we had a CERT Kadishala 2 months back about explainable AI. Then artificial general intelligence, that is also another. Artificial general intelligence is also AGI, also now getting discussed. And data science, machine learning, and system identification based studies for a system, observing a system for a long period, or suppose 10,000 days, how the sun's rise and sunset is there, and based on that, that's how the system behaves. Then based on that, the future also can be predicted. The studies are there, and or means based on that statistical techniques, some studies are there. Then what is happening? The computational fluid dynamics, where we are solving complicated partial differential equations like continuity, momentum, and energy equations. We are transforming them into some algebraic equation. Then we are solving using high-speed computers, and such studies or using data, having a lot of data or some using that system, some machine learning algorithms, you can predict. So that means now one is with solving governing equation, other one is only with input and output data. And so such approaches are there. That means nowadays or in the future, a lot of studies, even after 2020, a lot of studies you can see in the literature as the same problem have been tackled with the CFD and as well as machine learning techniques, and both may be from different domains, but this integration of knowledge domains and technologies are very important in the newer area. And in the computing also a lot of changes has been taking place, like quantum computing, edge computing, and cloud computing is changed to edge computing, and all these are such developments are there. And in the future, we need a lot of collaboration and between the disciplines and between the academic institutions, and then cross-disciplinary research is another important area. That means computer science, computer application, mechanical engineering, electrical engineering, electronics engineering, data science, statistics, mathematics. That means you can solve to get the artificial intelligence. All these areas and domains have to do work together, and also that means we also need some knowledge in all these cross disciplines. And even the medicine also now a lot of cross-disciplinary research between engineering and medicine is taking place. Recently, Kochi University had such a forum between the medical practitioners as well as the engineers to solve some real life problems. Or that means now the term generally discusses the translational research. Whatever the research will be, or through this collaboration and cross-disciplinary research, and we will be coming in some outcome-based or some products through this integration of knowledge domains and technologies. And data science is now in the future, the data science will have a lot of contributions or influences in the computational fluid dynamics based solutions also. And the machine learning that means a lot of, it is basically a subset of artificial intelligence develops dynamic algorithms. These algorithms also can predict solutions of a lot of problems, and also enabling computer programs to automatically improve their performance. That is another important. That means instead of the static computer programs, there will be now in the future dynamic computer programs and machine learning. All these will be there, and statistical methods will be there, and the predictions will be using data science and statistical methods, and decision making will be based on that. And now, if we are, these are from two different domains, CFD and the machine learning. But now you can see that in the Google Scholar, etc., a lot of studies are there enhancing computational fluid dynamics in machine learning, or machine learning based error prediction in CFD, and CFD driven machine learning, and CFD and machine learning methods for prediction. So these are together done. And one of the point is that machine learning is very fast and compared to CFD. And a lot of such in the March 2023, one of the paper there, they have studied evaluation of CFD and machine learning for predicting greenhouse microclimate parameters, and what is their objective, and then in the abstract it is telling that time required by machine learning models was much more less than CFD model. And then there is a fundamental difference. One, here we are solving the fundamental equations, governing equation. Other were based on the input and output data and based on the training, and we are predicting that. That means these two will be integrated or should be integrated for the future computations. And a lot of studies we can see that merging computational fluid dynamics and machine learning for different practical problem solving, and for the engine performance, CFD and machine learning together, both are studied, and the combustion in engines are studied using computational fluid dynamics as well as with machine learning techniques. That means the future computation will be an integration of the CFD, where the governing equations are important. We have to solve them in many situations, but machine learning will give us a lot of time saving and a lot of information, and we can compare this and we can have integration of that. And with this, I'm concluding my remarks in this valedictory section, and happy to see the session. A lot of papers have been, almost 70 papers have presented in this national conference, and thank you very much for inviting to this session. Thank you.
Sir, as a token of love from the royal family, we present your certificate.
Thank you very much. Thank you very much.
Sir. Thank you, sir, for the nice session and accepting our token of appreciation. Thank you, sir.
Thank you. Thank you.
Thank you very much, sir, for sharing your deep knowledge about the future of computational predictions with us. Your words were full of enthusiasm and valuable knowledge. The NCET 2023 team, with the whole RCET family, express our sincere and wholehearted gratitude for your presence, sir. Thank you. Now, I would like to invite Ms. Shabina, student of S4 MTech, Department of Computer Science and Engineering, for the participants' feedback.
Respected Principal, Dr. Devi Ma'am, CEO Selim Sir, all my teachers, specialized guests, and all my dear friends, a warm good afternoon to all of you. Here, I am so much proud and delighted to be a student of this college for this great program NCET 2023, which has been successfully conducting over 2 years. It was very good and really an interesting session. We got a clear view from Dr. K. Sharavanan sir on the topic emerging technologies in engineering and also from Dr. Fawaz TK on the topic the future of computational predictions. Thank you so much, sir. And also, it was nice to hear about different papers from the students. Actually, these are our great opportunities for the students to showcase their talents and also to express their ideas and views on various schemes. Apart from the academics, it is very important for the overall development of an individual. The whole college is encouraging us immensely, but we, the students, have to make use of these opportunities very well and we should not miss it. More and more active participation from the student side is expecting in the coming years. We thank especially our principal, Dr. Devi Ma'am, CEO Selim Sir, and the whole RCT family and the whole NCT associates for making this event so much wonderful. Hats off to your efforts, and it's really a great teamwork. And in the future also, we are expecting this new more programs like this, which is a very good platform for all the overall development of the students. And once again, from the bottom of my heart, I thank you so much, everyone, and thank you so much.
Thank you, Sabina, for your wonderful feedback.
Okay, thank
The
you.
end of a story is the new beginning of many others. On this note, let's conclude a remarkable, memorable, and knowledgeable valedictory session of NCT 2023. I invite Ms. Rehna CA, Assistant Professor, AD Department, and Coordinator of NCT 2023, for concluding remarks. Ma'am, please.
Thank you, Insha. Respected dignitaries in the offline and online. Now, we have reached the last part of NCT 2023. So far, we have listened session of eminent personalities. In the inaugural session, Dr. Sharavanan sir, in his topic, Emerging Technologies in Engineering, has delivered a warm thinking about the new aspects in engineering, and also he specifically mentioned artificial intelligence trend in 2023. In NCT 2023, we got 90 papers from UG, PG students, diploma students, PhD scholars, and faculty members from various institutions. The quality of papers presented in various tracks truly reflects our NCT 2023 theme, Spectrum of Opportunities. Various papers in the conference have taken us to the wisdom of knowledge, like automating the automation to replace repeatable process and reduce manual interventions with the help of artificial data analytics. Had a glimpse on transportation, structural, soil mechanics, and concrete technology. Mainly deals about design aspects of girder bridge, potential use of wastewater sludge, and replacement of coarse aggregates in concrete by waste materials. Also focused on CFD analysis, mechanical fabrications, and also various case studies, etc. We have gone through different machine learning algorithms used in diseases prediction, major security threats in website, and its protective measurements. Also focused on edge computing and its architecture. And just now, we have listened session of eminent personality in the valedictory speech, Dr. Fawaz TK, in his topic, Future of Computational Predictions, has clearly delivered various numerical methods for engineering. The guest speaker elaborated with various applications. More and more fields are merging towards the computational approach. Speaker also mentioned about integration of knowledge domains and technologies. Thank you so much for all your kind wishes and positive encouragement. Now, the most awaited moment. Here, we are going to announce the best paper awards in various tracks. So, starting with Triply Department, the best award goes to NCET serial number NCET 2023 W1 Smart Cloth Dry Management System. In the Department of Electronics and Communication Engineering, the Best Paper Award goes to serial number NCET 2023 EC2 titled Smart Medicine Vending Robot. Coming to the Department of Artificial Intelligence and Data Science, the Best Paper Award goes to serial number NCET 2023 AD02 Review of Driver Fatigue Detection System. Coming to the CSE department, the Best Paper Award goes to the serial number NCET CSE 008 Website Security Evaluation. Coming to the Mechanical Engineering Department, the Best Paper Award goes to the series number NCET 2023 ME01, titled An Overview on Nozzle Jet Impinging on a Vertical Plate. Next, Civil Engineering Department, the Best Paper Award goes to Analysis and with serial number NCET CE 006 titled Analysis and Rectification of Black Spots on SH69 of Kerala. That's the details regarding the Best Paper Awards. And here I conclude my words. Thank you all.
Thank you very much, ma'am, for your detailed concluding remarks of NCET 2023. Gratitude is the fairest blossom which springs from the soul. As we come close to our valedictory ceremony, I invite Dr. Shanavas S., HOD Mechanical Department and Coordinator of NCET 2023, to propose the vote of thanks. Sir, please.
Hello. Respected CEO Sri VP Salim sir, respected Principal Dr. Devi Madam, honored guest Dr. Fawaz TK and Dr. Saravanan K, respected convener Dr. N. Muthukumaran sir, dear coordinators and other college staff, and dear participants. A very good afternoon to one and all. Actually, it gives me great pleasure to deliver this vote of thanks So, on behalf of Royal College of Engineering and Technology, first I would like to express my deep gratitude to our guests, Dr. Fawaz TK and Dr. Saravanan K, for being part on this occasion and for addressing the research minds. Their ideas and talk on emerging topics are worthy and interesting and have widened the scope of this conference. Thank you, Dr. Fawaz TK and Dr. Saravanan K. I express my heartfelt thanks to Sri VP Salim Sir, CEO RCT, and Dr. Devi Madam, Principal RCT, for the great support, which in turn attribute to the great success of this conference. Again, on behalf of RCT, I express sincere thanks to the organizing team, Dr. N. Muthukumaran Sir, the convener, and Ms. Savida Vasudevan, Ms. Needu K, and Ms. Rehina CA, the coordinators of the conference, for the devoted endeavors. And finally, on behalf of Royal College of Engineering and Technology, I wish to thank all the participants and participated institutions for being a significant part of this conference. The participated institutions are St. Joseph College of Engineering and Technology, Pala, St. Kitts College of Engineering, Adi Shankara Institute of Engineering and Technology, Vellore Institute of Technology, Chennai, Government Polytechnic College, Kundankulam, Jyoti Engineering College, Thrissur, Tejas Engineering College, Sripadi Institute of Management and Technology. Once again, thank you, participants and participated institutions. Thank you all.
Thank you so much, sir. On behalf of this institution, the NCT 2023 team sincerely thank all the dignitaries for being with us this afternoon and enlightening us with their enthusiastic remarks. I shower my heartfelt gratitude to the RCT family for their wholehearted support and rendered in the success of this valedictory session. Thank you very much, everyone. Have a wonderful and fun-filled afternoon.
Okay. Thank you, the entire team for this enriching session. So systematically planned, very well organized. So I thank Dr. Madhukumaran and his team for such a nice conference in our RCT campus together with the association of other institutions. So on behalf of institution and management, once again, my sincere thanks to everybody with this conference. Thank you.
Thank you, ma'am. Thank you. The entire RCET fan has done it.